We are going to evaluate this integral by partial fractions. Let me take out the expression and try to break it up first. That means to resolve it into its partial fractions. So what you see here is a linear denominator. And what you see here looks like a linear, but there's a power 2. So this is a repeated linear denominator. So I will resolve it into the linear denominator. A linear denominator will have a constant numerator. And for the repeated linear denominator, I will resolve it into itself, which means power 2, and repeat it and reduce the power. So for repeated linear, the numerators will always be constant. So now my task is to find A, B, and C. Now for linear denominator, I can use cover-up rule to find A. As for repeated linear, you can use cover-up rule for the original form of the repeated linear. This is the repeat of this, so we cannot use cover-up rule to find C. So let's use cover-up rule to find A. I will copy this expression, but in copying, I will cover one of these denominator will be missing, so that's why it's like cover-up rule. So to find A, cover up x plus 1. So x plus 1 will be missing, so I copy the other denominator. So whatever has been covered, which is x plus 1, equate to 0. It means I'm going to substitute x equals to -1 into this expression. So for this, I will get 9/9, which is a 1. Let's do the same for B. Use cover-up rule to find B. I'll copy exactly the same expression, but cover up 2x minus 1 square. So between these two denominators, I'll cover up 2x minus 1 square and copy x plus 1. So wherever you cover up, equate to 0. So I will sub half into this part. I have -3/4 over 3/2, which gives me -half. Now I'm going to find C. To find C, I'm going to compare terms. To do that, I will have to first get rid of the fractions all over. So I'm going to take this denominator and multiply up. So this is what will happen. So this denominator multiply across. So with that, the first fraction multiply to this. Can you see x plus 1 will cancel with x plus 1? So I'm left with second fraction multiply to this. Can you see 2x minus 1 square will cancel with 2x minus 1 square? So I'm left with, finally for the last fraction, if I were to multiply to this, 2x minus 1 will cancel with one copy of the 2x minus 1. So I have x plus 1 and an extra copy of 2x minus 1. So I'm going to expand this. So this is what the expression now looks like, completely expanded. I'm now going to take the x squared term and compare. So if I look for the x squared term, I see one here, 4ax squared and 2cx squared. So comparing only the coefficients, the coefficients of x squared is just 1. The coefficient of 4ax squared is 4a. The coefficient of 2c x squared is 2c. Since I know a equals to 1, I will substitute the value of a here, so 4 times 1, and simplify this. So now I am ready to put my a, b, c values back into my partial fractions, as well as integrate at the same time. So let me now take the partial fractions and substitute back into the expression. So I have a over x plus 1, where the value of a is 1. I have b over 2x minus 1 square, where the value of b is negative half. I have c over 2x minus 1, where the value of c is negative 3 over 2. So now I'm quite ready to integrate. This looks like a logarithm to me. This one is the power rule. Perhaps I should rewrite this as a reciprocal power instead. And this looks like logarithm to me. So let me write it in a better manner first. So integrate 1 over x plus 1, I have ln. Integrate this power function. I have to increase the power by 1 and divide by the new power. However, because this is a linear function, I will also divide by the coefficient of x. So this is a logarithm function, and also I will have to divide by the coefficient of x. So now simplify. And you have the answer.